So in this video, we're going to be discussing two different experimental factors that can affect the rate of a chemical reaction. And the first one is the physical state of the reactants. So we're going to be drawing these back to the idea we discussed in the previous lesson of collisions as the basis for chemical reactions. So with the physical state, meaning if something is solid, liquid, or gas, essentially what it comes down to is the more particle motion that we have, the more total collisions that we have. More total collisions leads to more successful collisions. So in the gas and aqueous phases, those particles are really, really free to move around. Whereas in the liquid and solid states, not so much, especially solid. Most reactions that we study in terms of kinetics for the purposes of this course, at least, are either homogeneous gas or aqueous phase reactions for this reason. They tend to be easier to study in a lot of cases, and they tend to proceed pretty quickly, is why these types of reactions are common, because it's easier to get them to go at a reasonable rate. If a solid is involved in your reaction, it will often be slow, not always. But if a solid is involved, one of the reasons why solids tend to be slow is because the rate is also going to be limited not just by low particle motion, but also by the surface area of the solid. If you have a solid, let's say, reacting with a liquid, that like you drop a chunk of solid into a liquid that it's reacting with, the only place where those two different substances can actually physically collide is on the surface of the solid. So anything that's inside, if you have one big chunk, isn't available for collision. So only molecules on the surface, say on the surface of the solid, are able to collide with the other reactant. So what this means is that a solid reactant being divided into smaller particles, so if something is like a powder as opposed to one big piece, it's going to react faster. Because it has more surface area available. If we think about this idea of if we have one, let's say, cube of metal or something, make it gray, that we're submerging in a liquid, there's only a very limited amount of that solid that's actually on the surface of the cube. Whereas if we divide this up into a whole bunch of smaller particles, either just smaller pieces or powdered, now a much larger percentage of that material is actually exposed to the liquid and able to collide with it, and therefore able to react with it. So that's why you'll frequently see solids reacting in a powdered form as opposed to one big piece to get a decent rate, unless you want it to go slower, which sometimes you do. Then one big piece would be the way to go. So the other factor we're going to discuss is the effect of concentration on rate. And this is something that we'll discuss more in later lessons, the exact mathematical relationship, because there is one. But in general, a higher concentration, and when we're talking about concentration, we do mean molarity, moles per liter. We know that that means there are more reactant molecules in the same amount of space or per unit of volume. So if you're cramming more stuff into the same amount of space, it means that your molecules are just statistically more likely to bump into each other. So you get a greater number of total collisions, which leads to a faster reaction. So the exact mathematical relationship between concentration and rate varies, and is something we'll talk more about later. Oops, too many E's in that. That's better. So depending upon the reaction and depending upon the reactant, exactly how they relate can differ, but generally speaking, higher concentrations lead to faster reactions. So that is all for this video. We'll talk about 2 additional factors that affect rate in the next one.